Hello, back to chapter 8, quadratic equations and functions. Now we are working on section 8.6, further graphing of quadratic functions. The objective number 1 is to write quadratic functions of the form y equals a plus x minus h plus k. Let's go to the graphs of quadratic functions. We know that the graph of a quadratic function is a parabola, right? This is something that we know. If the quadratic is written in the form f of x equals a times parentheses x minus h squared plus k, then we can find the vertex, because if it is written on this form, h is going to be the coordinate x of the vertex and k is going to be the coordinate y of the vertex. Okay, and since we can find out a lot about the quadratic function before we ever graph it, it will be in our best interest to get the quadratic into the appropriate form so we can easily find that information. The techniques we use would be similar to completing the square. So let's go to the example and we will understand how it works. Let's say we want to graph this function here. F of x equals negative 3x squared plus 6x plus 4. And to graph, first we need to find, we're going to find the vertex, the axis of symmetry, and any intercepts. Before graphing, we rewrite the equation into the form that will communicate information about the graph. That's our purpose. Let's rewrite this equation using the format. Is this one we have seen before. F of x equals, let me write down here so you can remember. We will write on this format, using this format, f of x equals ax, a times x minus h squared plus k. Okay, this is the format that we're going to use. And we have the equation here. The first thing we're going to do, f of x equals, let's the first thing is to find a. There's a here, and this a we can see is going to be the coefficient of x squared. Okay, because we don't we can factor this out. Negative 3 times x squared, x squared minus 2x, because this negative 3 times negative 2x, positive 6x, okay, plus 4. Now check this, we have this expression here that we want to complete squares. We want to complete squares to use, to transform, to change this into a square of two terms, two parts, two terms squared. Let's work this out. We will complete the square here. Let's actually work only on this here, x squared minus 2x, and we're going to complete the square. This is going to be a squared, right? And this is going to be 2ab, and we have to find out b squared. Okay, let's work on 2ab. 2 times 1 times x, you can write like this, right? That means a is x, we have checked this before, and b is going to be 1, right? So we found that to complete the square, we're gonna need to use this b here, b equals to 1. Now we know b equals to 1. Let's erase this. We don't need this anymore. B equals to 1. Let's complete the square right here. F of x equals negative 3 times x squared minus 2x plus b squared, which is 1 squared, 1. We have to balance, we have to rebalance the equation, because now, check, we have this negative 3 here in front of the parentheses. When we multiply by 1, negative 3 times 1, we're going to have negative 3 in excess. It's changing the value of the equation in minus 3, like negative 3. So we have to add 3 here to balance, because now this will make the equation equivalent to the previous one. That's the purpose, to make the equation equivalent to the previous one. And keep working, let's keep working. We can rewrite this expression, this quadratic equation, as the equivalent. F of x equals negative 3. A is x minus b is 1 squared plus 4 plus 3 plus 7. And check the format of this equation. Is the same we are looking for, right? Now a equals negative 3. Let's write down here. A equals negative 3. And h equals to 1. And k equals to 7. Well, what's good about this format here is that it's going to be easy to find the vertex, because the vertex is the point h, 1, and the x equals 1, and k, x equals 7. This is going to be the vertex by definition. And we also can identify, we know that the vertex is located in the line of symmetry, the axis of symmetry. And we can say that the axis of symmetry is going to be x equals 1. X equals 1 is the axis of symmetry, is the position, is where the vertex is. And we will see, we will kind of visualize this on the graph a little bit later. Now, to help graph, we will find the intercepts. For f of x equals negative 3 times x minus 1 squared plus 7, the x-intercept is where the graph intercepts the x-axis, is where y equals 0, and the y-intercept is where the graph intercepts the y-axis, is where x equals 0. So first one, y-intercept, where x equals 0, okay? So we plug in 0 into the equation, we're going to find the y-intercept. The y-intercept equals f of x, which is negative 3, then you plug in x equals 0, 0 minus 1 squared plus 7. This will be 0 minus 1, negative 1 squared, 1, positive 1, negative 3 times positive 1, negative 3, plus 7, 4. That means y-intercept equals 4. Okay? So we found y-intercept. The next step, let's find x-intercept. And x-intercept is going to happen, is going to occur when y equals 0. So let's find x-intercept. Get the equation, f of x equals negative 3, x, f of x equals negative 3, x minus 1 squared, right? Minus 1 squared plus 7. Oops. Minus 1 squared plus 7. make y equal 0. That means this. F of x equals 0. That's the same thing as y equals 0. And we will have negative 3 x minus 1 squared plus 7 equals 0. Let's move everything that's not this parenthesis here squared, where we have our variable. Let's move everything to the right hand side. Okay, so let's move this 7, negative 7, subtract 7 from both sides. Then you will have, this is gone, so negative 3 x minus 1 squared equals negative 7, and then divide both sides by negative 3. Negative 3 here and there. Let me split this, we can continue working on this space. Simplify, so x minus 1 squared equals what? 7 over 3. Okay? What should we do now? Remember, look at this. We can actually use the square root property, and we will apply a square root here. We're going to use a square root here, and another one over here. But don't forget what? Positive or negative. Okay? The square root of x minus 1 squared equals positive or negative square root of 7 over 3. Let's, at this point, we can find that x minus 1, we can simplify this, right? Equals positive or negative square root of 7 over 3. That means x equals negative 1 plus or minus square root of 7 over 3. And that's it. Those, we're going to have two different x-intercepts. So remember, this are the x-intercepts, are the points, the 2 points where the graph intercepts the x-axis. At this point we're going to be able to plot the graph. We have the vertex. The vertex is 1 and 7. X equals 1 here, and y equals 7. And this is the vertex. The symmetry axis is x equals 1. This line that I'm drawing here is the symmetry axis. That is a reference, an important reference to draw the graph. The y-intercept is going to be x equals 0, y equals 4, right here. This is the y-intercept. And now, finally, the x-intercepts are the points 1 plus 7 over 3, square root of 7 over 3. And the other point is and 0, obviously, because it's here on the x-axis, y equals 0. And the other one is 1 minus square root of 7 over 3 and 0. 7 over 3 is kind of 2 point something, right? 2 point something. That means this this whole thing. Let's do some calculations here. Is going to be around 2.7. This here is going to be, if you type in a calculator, you're going to find something approximately equals to 2.7. And type this in your calculator, and this is going to be something approximately equals to 0.7. Negative 0.7. Negative 0.7. Let's find these points on the graph. Approximately 2.7, somewhere here, right? Somewhere here. And approximately negative 0.7, somewhere here. This is approximately. Now we have several points. We have several points that we can use to plot the graph. Let me use a different color, maybe red, and connect the dots, connect the points. This is the vertex. Remember these arrows here, these arrows are kind of an important thing because the graph goes all the way down to infinity. It continues, it goes all the way down to infinity. This is a sketch, it's a rough sketch of the graph. This is how you do to manually plot, to manually draw the graph by using as a reference a few points and the axis of symmetry. Next objective, number 2, derive a formula for finding the vertex of a parabola. So this is one way of finding the vertex, is changing the equation into the right format. So you can see, you can find here, as we have done, we can find h, you can find k, oops. You can find h, you can find k, and then you find the vertex, right? But you had to change, you had to manipulate and change the equation into a different format to be able to do this. Another way, another method is by actually using a formula to find the vertex of the parabola. And the formula to find the vertex is going to be based first on this number here, which is the coordinates of the axis of symmetry. And you can actually figure it out for yourself, but this is going to be the coordinates of the axis of symmetry. This is going to be the midpoint between the x-intercepts, the two x-intercepts of a parabola. And this is the coordinate of the axis of symmetry. This is the x, and to find out y, you plug in negative b over 2a into the function. So y is going to be f of negative b of 2a over 2a. This is the x coordinates and y coordinates of the vertex. Example number 2, find the vertex of the graph of f of x equals x squared minus 4x minus 12. And then just apply the formula. Let me write again the formula here. Negative b over 2a and f, you plug in negative b over 2a in the function. Calculating, identify, the first thing, identify b and a. b is negative 4, this is b, and a is 1. a is 1. Okay? So we will have negative b is negative 4 over 2 times 1. And then plugging this into the function. What this? Let's find out what this is going to be. Negative with negative positive. Positive 4 divided by 2. 2. Plugging here. 2. F of 2 equals 2 squared. Let me fix this. 2 squared minus 4 times 2 minus 12. Okay. F of 2 equals 2 squared 4 minus 8 minus 12. F of 2 equals negative 16. And we have the coordinates. We have calculated this, right? Negative with negative positive. Positive 4 divided by 2 is 2. Let me substitute, let me change this into number 2, and f of 2 equals negative 16. Great, and finish with this objective. Going to the next one, next objective, which is to find the minimum or maximum value of a quadratic function. The quadratic function, whose graph is a parabola that opens upwards, has a minimum value, and the quadratic function whose graph is a parabola that opens downwards has a maximum value. The f of x of y value of the vertex is the minimum or maximum depending on the kind of parabola. Let me see. Let me just draw the pictures here so you can understand. This is a parabola that opened upwards, and this is a minimum, right? If open upwards is a minimum, you can have a minimum. This point is the lowest point. If you have a parabola that opens downwards, the opening is downwards, so you have a maximum. This is the highest, the top of the parabola. And we can apply this to the example. The Utah Ski Club sells calendars to raise money. The profit P in cents from selling X calendars is given by the equation. P of X equals 360 times X minus X squared. What is the maximum profit the club will earn? So we want to calculate, we want to find out the maximum profit. This parabola, we can see if the parabola is pointing downwards or upwards by checking the coefficient A. And the coefficient A is the coefficient of x squared, right? This is going to be the coefficient A here is going to be -1. If it's negative, the parabola is pointing downwards. If the coefficient is negative, the parabola is going downwards. And the function is going to have a maximum. And that's what you're looking for. This point here, this maximum of the parabola. Okay? This is what we're looking for. And what are the coordinates of this point here, this maximum point? Remember, before we have seen how to calculate what? The vertex. Yes, the minimum point or the maximum point, depending on the position of the parabola, is going to be the vertex. The vertex. This point here or this one there. Those points are the vertices of different parabolas. Okay. That's the formula that we're going to use. This is the formula that we're going to use to find actually the maximum profit. The maximum profit is the function, but the first thing that we will find is the x that makes it maximum. The x that makes it maximum is the x coordinate, which is given by -b over 2a. Remember, this is the x coordinate of the vertex, which is equal. Use blue, I like blue better. Okay, -b over 2a, find b, 360, a, again, a, -1, -360 over 2 times -1. And this is going to be negative. Here with negative, we're going to have a positive, 360 divided by 2, 180. 180 is the number, the quantity, the amount of calendars that is that they are selling to have the maximum profit. And let's plug in 180 into the equation. P of 480 equals 360 times what? Times x, and this is x. This is x, right? this is 180 minus what? Minus x squared, minus 180 squared. And you can actually calculate, you can use your calculator to find this. But let's do something different here. Let's factor this out, because this is 2 times what? 2 times 180. 360 is 2 times 180. Times 180 minus 180 squared. See? I'm just avoiding to use my calculator here. I'm kind of trying to do it just by factoring and simplifying. We will have 2 times and 2 minus 1, 180 squares. That's going to be just 180 squares. Now you can get your calculator and find the results. And the result is going to be, I have it calculated here, 180 squared is 180 squared is going to be 32,400 cents, because this is given in cents. The problem says this is given in cents. Now, if we want to represent this in dollars, we divide it by 100. So P 180 equals, dividing this by 100 is going to be $324. That's the answer. And this is the last example of this section. Thank you very much for watching.